Now, remember this, and this is very important as this is electromagnetic spectrum. To remember this particular case, we need to ask, I have remembered this as long range UVXY. I have learned it as Lormir UVXY. Lormir UVXY, where LO defines long range radiations, R defines radio wave frequency, which comes somewhere here. M defines microwave. IR defines infrared. You're going to move. And somewhere A here, almost 10 raised to power 15, is ultraviolet as well as visible region. See, we can see only a very small kind of, we can say, frequency at which we can see, and this is known as visible region. That means our human eyes are capable to see only a small frequency, depending upon hertz, quite obviously, which we can see, and that's why this is known as visible region. And this depends upon almost 10 raised to power 15 hertz, visible region. It lies somewhere here. Okay, now ultraviolet has a point, visible, and last one we have X-rays and gamma rays. This Y defines gamma rays. Now, what actually they want to suggest us? Long range waves are nothing. They just show that they have hertz frequency at very. Now the radio waves, you have already heard about the radio waves, like AM, FM radio something. So which we need to use for broadcasting. These are radio waves. Now microwave, microwaves we use in our homes for cooking and something. IR, infrared radio wave, very important, but we will study about them in higher classes. Okay. Studied X-ray, gamma rays, alpha rays, beta rays, gamma rays. We have studied in the other force model. So these all things are related to each other, and this is known as electromagnetic spectrum, which depends upon the increasing order of frequency. So this Lormir UVXY depends upon the increasing frequency. And wavelength and frequency are inversely proportional to each other. So wavelength is going to be decreased. Suppose it's somewhere 10 raised to power 15, then goes to 12, 10, and so on. It's going on decrease up to minus 18. And it is in the form of meter. Okay. Now, one thing you must know that I have given you a brief idea about visible region. The visible region which is visible to us, the magnetic spectrum which is visible to us is known as visible region, in which you have seen the all colors, the violet, indigo, blue, green, yellow, orange, red. You have heard about rainbow, right? You know that in rainbow there are 7 different colors. You know that the white light is actually a mixture of 7 different colors. You know that very well. Okay. So this visible, it contains your higher frequency, because we are going to in this way in higher frequency, and this is our 10 raised to power 0, 10 and here 10 raised to power 24. And it lies somewhere here. That means the red color is at lower frequency and the violet color is at higher frequency. Why I'm stressing on this topic so much? Because later in this chapter you need this topic, the vibrure, the frequency, the wavelength. To the last one. Okay. Now, since we have related these all things with light, so the speed of light is a measure, is a basic measure to relate these all, we can say, standards, these all units. So we have given a idea, that is, just a second. C equals to mu lambda. Now, what is C, what is mu, and what is lambda? The C here is known as speed of light, mu, and lambda. This is pronounced as mu, which seems to be V, but this is mu, which is you can say the notion of frequency, and this is lambda, wavelength. Now, talking about the units, I had already told, you know about the speed of light. This is 3 into 10 raised to power 8 meter per second. You know that very well. Okay. Now, the frequency, I have already told that frequency tells you about the number of waves in 1 second, the number of waves per second. So its unit must be per second, or we can say its unit is hertz. Okay. So nu per second or hertz. Hertz was actually a scientist who described about frequency. So just to give that particular scientist the owner, we have given the unit of frequency, the name hertz. Okay. And the last one is wavelength, lambda. Lambda is nothing. Its unit is just same as the unit of length. So its unit must be in meter. Okay. Now, this is a general formula on the basis of which we would solve some numericals, which are very important for your exam point of view. In spite of that, we have another method, another measure, another unit to show these electromagnetic radiations, and that is wave number, which is denoted as mu bar, which is equals to 1 over lambda. Okay, so its unit must be per meter. All right, so these all four were methods, these all four postulates were explained, which are very important. First one, he told about that there are electrical as well as magnetic, both radiation, but they are perpendicular to each other. Second one, he told us that these radiations do not need any kind of medium. They can also travel in vacuum form. Thirdly, he said that there is a kind of electromagnetic spectrum, which I have explained, which depends upon increasing order of frequency, or we can say decreasing order of wavelength, which is very important. I have remembered this and I have explained this as lower mid UV XY, long range, microwave, infrared, ultraviolet, visible, X-ray, gamma. Visible is very important for us. Now, visible means the red color, the violet color. The red color is at the lower frequency and the violet is at higher frequency. And lastly, these some numerical subscripts. Okay, this was all about the wave nature of light. I hope I have made clear to you. What's the time left? Okay. Now, on the basis of these 2-3 formulas, let's have a simple numerical, which will make your concept much clearer, and then we will go to our next topic. Let's have a simple. Okay. In our NCRT, we have an example. Calculate wave number and frequency of yellow radiation having wavelength 5800 angstrom. So let me write. Firstly, he said there is wavelength which is equals to 5800 angstrom. I hope you have heard about angstrom. In the first chapter, we have different type of units which have like nanometer, we have micrometer. Please keep them in mind. You must remember this. That's why this is included in your first chapter. That we have centimeter. You know that. I don't think so. That we should explain this. 10 raised to power minus 2 meter. Then we have micrometer, which is 10 raised to power minus 6 meter, nanometer, 10 raised to power minus 9 meter, angstrom, 10 raised to power minus 10 meter, picometer, 10 raised to power minus 12 meter. Please keep in your mind these 4 to 5 terms. Please keep in your mind. Okay. So now we have given wavelength which is equals to 5800 angstrom. That means this is 10 raised to power minus 10 meter. So we will solve it. Firstly, we have the question, calculate the wave number. Yes, calculate the wave number. I have already told you about the wave number, which is denoted as nu bar. That is equals to 1 over lambda. So 1 over 5800 into 10 raised to power minus 10. Or we can solve it 1 over 58 into 10 raised to power minus 8, which would go 10 raised to power 8 over 58, and we will solve this. Next, we have the question. Calculation of the frequency. What should be the frequency? So about the frequency, we already have a formula, that is C equals to nu lambda. So from this formula, can we calculate nu? That must be C over lambda. C equals to nu lambda. C over lambda equals to nu. Yes, or we can say C over lambda equals to nu. We have so many different formulas on the basis of this particular concept. Okay, so on the basis of this, we can calculate our frequency. We have speed of light, 3 into 10 raised to power 8. We have our frequency wavelength, that is 5800 into 10 raised to power minus 10. We will solve this, and the whole solution would be ours. Okay, so this was very important. This is very important for your exam, not only exams like school exam, but your competitive exams too, for your higher classes too, for your 12th class too. Okay. So I don't think so much left in this particular topic. Let's move to our higher topic, that is the particle nature of light. What is particle nature of light? At the end, ask to, when I say that if you have any kind of doubt or query, please ask. You must ask. Don't you dare to leave the class. Every day you just leave the class whenever I ask you about the queries. It's a very new topic, students, and you must know. I don't know how much I am delivering to you. How much are you grasping? Okay, so please ask me. Please tell me that you have studied this. You have come to know about this topic. Okay. All right. So what I have already told you till now, it's almost 10. Okay. Till now, we have studied about the dual nature of light. That means our light is made up of two things. First one is particle nature. Second one is wave nature. About the wave nature, I have already told you the frequency, the wavelength, the electromagnetic spectrum. Now the second thing is the particle nature of light, which is very important. Okay, why do we need to study the particle nature of light? See, the students, we have just discussed about the wave nature, but there were some observations as well that when a ray, or we can say when a ray of light strikes a metal, एक ray of light hai and it's striking a metal. So what are the observations? There are some electrons emitting out. There are some kind of, you can say, energy emitting out. This was not explained by wave nature. This was the first example. Secondly, he did not tell about the temperature of hot body. For example, if I'm saying that we are burning our iron. In the starting, it is a little hot when we are burning. It seems to be red. After some time, when we burn it, it seems to be more red, dark red. Then it seems to be blue light. It starts to emitting blue light. At the end, this temperature becomes so high that it starts emitting almost bluish violet light. So this means that these are the frequencies which are going to be increased from the lower to the high. That means this is a very simple concept that whenever we increase our temperature, the frequency starts increasing from the lower one to the higher one. This is a very simple concept. I hope you have understand that whenever we increase the temperature of our increase of the temperature, the wave, the frequency starts increasing from lower to the high, and it starts some kind of energy. It starts emitting some kind of frequency. Okay, and in this way, we came to know about black body, which is known as ideal body also. We will discuss this in detail, that a black body or is basically taken as an ideal body, which explains that it absorbs and all kind of radiations. I'm repeating it again, that a black body is known as an ideal body which absorbs and emits all kind of radiations. Okay, we will visit class. So let's start with now the point here comes to when we have studied about the black body and the black body radiation, what we came to know that whenever it absorbs and emits all kind of frequency, all kind of radiations, and whenever it emits the radiations, this is known as black body radiation. But these were not continuously radiation, these were not continuously in the wave nature, they were discrete in nature. They were not continuous. So the scientists said this is not a wave, this is the radiation only have the wave nature. They said that there must be a particle nature, and they gave it a particular name, that is quantum, which means packet of light. So according to them, a black body or a hot body do not release continuously energy in the form of wave. In fact, it releases energy in the form of packet because it is discrete. It is not continuous in nature. Okay, so this is known as quantum or packet of light. In fact, they also give us numerical relation, that is E equals to h nu. That means energy is directly proportional to frequency, and after removing the proportionality constant, we have E equals to h nu, where h is known as Planck's constant. Since Planck was the scientist who gave all the idea, who gave the idea about quantum, who gave the idea about black body, so that's why we have given him the name h equals to Planck's constant, which you have to remember, okay? Which is equals to 6.6 into 10 raised to power minus 34 joule per second. You have to remember the h value, 6.6 into 10 raised to power minus 30. Now we have E, we have H, we can calculate mu, or if we have mu, H, you also know, we can calculate the E. So this was the first concept of the particle nature. The second was the photoelectric effect, which I have given you idea that whenever a light strikes on a metal, it does not give the actual wave. What happens to that? This is known as photoelectric effect, which we will study in tomorrow's class. Okay, till now, if you have any kind of doubt or query, ask me. Sir, can we have unmute our students?